Hi everyone and welcome back to Mechanical Vibrations. Today I've got something really awesome for you. Of course you already have seen my single degree of freedom system and we discussed free and forced vibrations of single degree of freedom systems. So today it's time to move on and the next topic will be about systems with multiple degrees of freedom, and for that I have found another card and another spring. So let me try to modify this setup on video such that we are able to look at systems with 2 degrees of freedom. And that will be very spectacular. At least it's a topic that I really like and I hope you will like it too. So I will add another card and another spring. Oops. This was what I was already afraid of. Let me move it more to the sides. Like this. Yeah, it's more or less centered. All right, so now we have a system with 2 degrees of freedom, double mass spring system. And what I am going to explain to you is how are we going to determine the natural frequencies of such a system, its free vibrations and its forced vibrations. So let me start off by demonstrating the natural frequencies of the system. And I think it's important, the first important point is that a system with 2 degrees of freedom has 2 natural frequencies. Let me recall what a natural frequency is. So a natural frequency is a frequency in which the system is able to vibrate when there are no external forces acting on this system. Well, let me give you a quick demonstration. If I take both cards and move them a little bit to the right and release, we see that it vibrates very nicely in a particular frequency. This is the first natural frequency of the system. But there is a second one. If I give the cards an excitation like this, they vibrate in a higher frequency. This is also a natural frequency. So this system, 2 degrees of freedom, means that there are also 2 natural frequencies. So the first topic of the next block will be how can we determine these natural frequencies from the equation of motion? What we will need for it is the homogeneous equation of motion, so no right-hand side forces. And we can also ignore the damping, because the natural frequencies themselves do not depend on the damping. So once we have established that, we will also see that we are able to determine this ratio of amplitudes of both, in this case, both cards. So we see that the first natural frequency corresponds to this vibration behavior. Both cards are doing the same. We could express this as an amplitude ratio of 1 to 1. Okay. And this second natural frequency, the vibration ratio, you could describe it as 1 to minus 1. Okay, so these ratios, they describe how the system is vibrating if it is vibrating in the natural frequencies. Well, these ratios are called so-called natural modes or eigenmodes or vibration modes. And what we will do is we will not only explain how to determine the natural frequencies, but also how to find these natural modes. Well, what I just did was in fact an example of free vibrations. We will see that in free vibrations we can describe any motion of the system, so any possible motion of the both cards, in terms of vibrations with both natural frequencies in corresponding natural modes. So that basically means that if I excite the system exactly in just one of the 2 modes, the vibration will be exactly in that mode. Okay? But if I just give the system an arbitrary excitation, not perfectly with one of the modes, you can see that the response is now not a nice motion in just one frequency, but there are 2 frequencies in this response. So this will be in general a superposition of both vibrating frequencies. And I will show you that in a free vibration lecture. Then we move on to forced vibrations, and this is a bit difficult to demonstrate, but I will show you how to compute forced vibrations as well. So what if there are forces acting on the cards, or in this case I will excite the base of the spring. We will see that it is also possible for this system to resonate if the system is excited in one of the two modes. Let me try to do this. It's kind of complicated. Let's first do omega 1. That is kind of okay. First natural frequency. So I excite the base here by moving my fingers a little bit left to right, and you see that for me it's very easy to make the system vibrate like this. But it's also possible to show resonance in the second natural frequency. It is slightly more complicated. Let me see if this works. No, this is the first again. I need to move faster. Yeah, it's like this. Great, it worked, and fast. So you see that now I'm able to excite the system in the second mode. Oh, I'm very happy that this worked. By moving the base exactly in the second natural frequency. Okay, so we will also explain that. So how to determine natural frequencies and modes, what are the free vibrations, what are the forced vibrations, and then finally I will finish off with like a special case that will conclude the 4th video lecture. So there will be 4 video lectures in this block. I will explain everything based on this 2 degree of freedom system, but these ideas can be generalized to other systems with an arbitrary number of degrees of freedom. So if you have some system with 10 degrees of freedom, you can write them in the same matrix vector form, the same linearized form, and then all the same strategies apply to systems with more than 2 degrees of freedom as well. So I hope you like my experiment, and I hope you will like the video lectures in this block as well, and I will see you in the next one. Okay, take care, bye bye.